Good evening, and you're very welcome along to this evening's launch of our sustainable 3D printed range of custom foot orthotics. It's an exciting evening for Firefly, and there's been a lot of work involved in getting to this point. So we have over 70 people who have subscribed to this evening's webinar. So thank you very much for all taking the time to join us this evening. We hope we won't keep you too long. We hope to wrap this up in about 20 minutes, maybe 25 minutes. My name is Connor. I work in the kind of marketing department of Firefly. I'm joined tonight by Firefly CEO and founder Martin McGeough. So it's great to be here this evening, Martin. It's an exciting time for Firefly. The development of these products has been in the offing for a while now. So tell us a little bit about why we're here. What was your ambition to deliver this range of sustainable products?
Okay, thank you, Connor, and good evening, everyone. Welcome to our webinar. So, question is why? It starts with a why, and my answer to that is that there's never just one reason. And what you find is that there's several things come together that creates the need or the desire for what we've created. And the first was that probably nearly 10 years ago, Firefly got involved in a EU-funded a footprint project. We were an Irish company working with several consortium partners in the UK with Jim Woodburn's team up in Glasgow. A lot of you would know Jim. Jim led the consortium, and we worked with companies based around Europe on the design of novel foot orthoses and ankle foot orthoses. And at that time, the term was rapid prototyping. Mm-hmm. And that term rapid prototyping has evolved to the term 3D printing. And what we were looking at was how do we use additive manufacturing techniques? So that's building up in layers that creates less waste rather than the traditional grinding or milling where you're subtracting material and creating a lot of waste. Mm-hmm. The key thing about that was really about software. So these were digital software processes to design products that were functional and aesthetic. Mm-hmm. And they were also looking at new materials. So it really began with that possibly 10 years ago. But really the technologies have moved on, and really what I was doing was watching that space and looking at, well, what's happening in the software field, what's happening with the design tools, what's happening with the material technology, what's happening with the 3D printing machines, and when does it make commercial sense, and when does it make sustainable sense for us as podiatrists to really get on board with 3D printed products.
And there's also, the other side of it is there's a demand for, we're all aware of the impacts that plastics have on the earth and our lives and the environment. So is there a demand, or has there been a demand from the Firefly customer base?
Without a doubt. So one of the questions that I answered, or one of the points I made there, was the software. So the software needs to evolve. The other was a customer base, a discerning customer base in podiatric medicine that were asking us for what were we doing in terms of sustainability practices. Mm-hmm. And one of the first things we did was move to biodegradable plastic bags instead of using consistent single-use plastic in the packaging. At the same time then, the material technology evolved to the point where rather than using just simply 3D printed nylon or plastics, we could make a choice to use 3D printed sustainable plant-based material. And that's the range of products that we're launching right now, Connor.
Okay, so you spoke a little bit about the manufacturing process. We'll speak a little bit more about that with our R&D director Yari later on. But there's if you contrast the traditional manufacturing methods, vacuum forming, with what happens in the manufacture of these, it's worlds apart, isn't it?
Yeah, it's just a very different process. So traditionally we either use vacuum forming or we use direct milling, and therefore both of those manufacturing processes have limitations, and all of the existing labs work within those limitations. And if you think back over the last, or if I think back over the last maybe 30 plus years, foot orthoses have not changed. Mm-hmm. When I first qualified way back in 1989, foot orthoses looked the same as they do today. So what really changed was maybe material technology. We started offering XT Sprint, lightweight carbon fiber shells. We were able to offer TL2100. We were able to offer different mixes of EVAs, but fundamentally the shape and what a custom-made foot orthotic looked like and what it did in terms of its offloading ability was limited by the manufacturing processes. When you look at 3D printing, the software now allows us to design anything we want. So complex shapes, meshes, movable parts, and it's really up to us as the podiatric profession to determine, well, number one, what's the diagnosis? How do we want to offload that? Now start using our creative minds to say, well, maybe the traditional designs, maybe we could do something better. So the range we've created initially are really as state of art. Mm-hmm. So the range that we're presenting to the podiatric profession today are us really wanting to replace polypropylene. Mm-hmm. So fundamentally, they're as good as polypropylene, but they're a sustainable 3D printed plant-based material. Yeah. The next phase that we want to move to is the pathology precise orthoses, and that's where I've been discussing with lots of colleagues, what would you like to see in terms of your offloading designs? And you know, we laugh, we design things that are wave shaped. We can design different patterns with little nodules that are smaller or, you know, bigger, and it alters then the stiffness characteristics of the material. So, you know, we've now chosen 7 key pathologies that we as podiatrists treat on a daily basis. Every single one of us see them in our clinics. You know, how do you offload a second MTP joint synovitis? How do you treat a plantar calcaneal spur? How do you create, you know, offloading of the peroneal tendons? Mm-hmm. How do you offload a tibialis posterior tendon? So we're now going to start looking at how do we create designs that are specific to that pathology. Yeah.
But even within these products that we're launching today, there are some interesting design features that are possible with 3D printed that might not be possible with the polypropylene or the traditional orthotic.
Yeah, well, absolutely. I mean, this is one that we will offer at the moment, and this is a sulcus extension. So it's an extension of the shell, 1 millimeter thick, and finishes at the sulcus. And what this now does is protects the top cover material that we would put on as cushioning and offloading for the metatarsal heads. So this now gives you a more robust, longer lasting custom-made foot orthoses, and that's made from the sustainable plant-based material.
Okay. What does it mean for the podiatrists when they're prescribing this device? I mean, should they be thinking differently about the prescription that they're writing?
Well, right now, what we've created is a digital end-to-end process. So what we have is we have our Fusion app, which is downloaded onto our iPad, and we have a structure sensor scanner, and we also have some gadgets here which can position the foot. So some podiatrists haven't moved to a digital format because they're slightly concerned about the positioning of the foot when you capture the anatomical position. So this is one gadget called a sulcus stick, quite easy to use, £50, cheap and cheerful. That does require the patient to help in terms of, and it's in a supine casting position or scanning position. Yeah. We have another system here which is called a ScanMate. This is a little bit more complex, a little bit more expensive, so you could be looking at maybe £500 for something like this. But this can plantar flex the first ray, this can position the foot relative to the ankle, and also can be used for Ritchie brace manufacturers. So we're in discussions with our licensed partners. Could we now look at scanning digitally for Ritchie braces? So moving to that sort of digital end-to-end solution. In terms of writing the prescriptions, they're fundamentally the same. So our order form has now been translated into the iPad, and it's pretty much intuitive. It's, if you're a podiatrist and you're involved in the MSK world and you're using our current paper order forms, then this will be pretty much straightforward. It just means that the process is much faster, it's much cleaner, and I just think it's kind of where the world is going.
How does the the sustainable 3D printed product compare price-wise with our other materials?
Well, what we've done is, in this case, we've positioned it at the same price as polypropylene,
Okay.
which is really quite exciting because, you know, we're not putting an extra price tag on it based on all of the software evolution and all of the new innovative materials. What we're saying is, this is a sustainable plant-based material. It replaces polypropylene, and you know, it's at the same price.
Okay.
So we're not trying to, you know, make a differential that keeps people using plastics.
Okay. Just to say, if you are interested in digital scanning, if you're aware of it, but are reluctant, or you know, you've got some reservations about moving to digital scanning, products like the Sulca stick and the ScanMate we can supply. If you're interested in using those in your clinic, we can supply them to you. You just need to ask us about that. You can contact us info@firefly.ie or contact us through our social media channels, and we'll be happy to answer any questions or to ship them out to you. And
now, maybe can I make just one comment there? I mean, for all of us that maybe use foam boxes, plaster of Paris, you know, the little you know, socks, it's the same concept remains, in that, you know, you need to take a little bit of time to perfect how you use the new technology. So, you know, it's like when you first did your first plaster of Paris cast or your first foam impression. You know, you take time, you perfect it, you get the foot in the position you want, you take the quality scan in this case, and what I would like to say is that I'm really quite content with the quality of the scans, the accuracy of the scans, and the data that we've been using in the manufacture. So for, again, the last 12 months, we've been doing plaster of Paris, we've been doing foam impressions, we've been using scanned images, and we're happy with the consistency.
tell me a little bit about how fusion and scanning has been implemented in our clinical division. You know, the efficiencies that our podiatrists are experiencing using the
Yes, so here in Ireland we have several Firefly foot and ankle clinics, and particularly in the Republic of Ireland, where we compete with physiotherapists for the provision of custom-made foot orthoses to MSK patients and orthopedic patients. And we've introduced the Fusion app, the 3D you know, scanner, the structure sensor scanner, the use of either something like a ScanMate or a Sulca stick, or sometimes people just capture the foot in whatever position they want. And it's made that digital end-to-end process really efficient and seamless. And the big thing is the fast turnaround times.
Mm-hmm.
So patients get their products back much quicker. The minute they complete the scans, complete the order entry and prescription and press the button, it's in our lab.
Mm-hmm.
So the notion of, you know, drying casts, posting casts, so there's a lot of money saved, there's a lot of time saved, no more messy casts, no more messy floors.
Yeah.
And patients absolutely love it because we can show them the image of their foot as a rendered plaster of Paris image, or indeed just as their foot.
Yeah.
So it's quite good from that perspective too.
Another interesting and useful feature of the Fusion app is because the Fusion app captures the anatomy of the foot in a photographic rendering. If the podiatrist wants to exactly locate met pads or plantar fascia grooves, you can mark the patient's foot with a marker, and that's captured in the scan, and it's mapped directly to the orthotic device.
Yeah, correct. So yeah, it's nearly like a photographic process as well. It's captured in the 3D scan as a second met head or a fourth met head, whatever it is. The big thing to bear in mind is that that's a non-weight bearing scan, which is typically what podiatrists do. And then you manufacture that onto a product, and then you've got a dynamic loading foot. So sometimes they alter, the position's not exactly bang on,
Mm-hmm.
but most podiatrists would know that.
Yeah. But for the 3D printed orthotic, we can map directly from the scan, and there's no, I suppose from our technical support team and our operations team, they're not relying on maybe a hand-drawn diagram to try and identify where the fascia groove is going to be placed.
Yeah, so you get better accuracy from that point of view, and also, you know, two of the little features that we've designed with the current range is the sulcus extension that I mentioned, but also you can have a built-in metatarsal pad. So rather than a technician attempting to position the met pad, glue it on and stick it on, this is actually built intrinsically into the device.
Mm-hmm.
All of the other prescription type of concepts that we would request are also available: intrinsic posting, rear foot extrinsic posting, etc., etc., etc.
One of the central people involved in the sustainable 3D printed product was our research and development engineer, who's not with us, but we'll go over and join him now with a Zoom call.
In this part of our presentation, I would like to introduce you to our engineer, who also has headed up our research and development with regard to our software development, and then the advent of the use of sustainable plant-based material. So you will have heard of Harry Potter. You will also have heard of Gandalf, but very few of you will know of Jari Palari. So Jari Palari is our wizard who can straddle across various software platforms and can help us design the products that we feel will be innovative for the future in terms of our offloading strategies. So I know Jari from our EU footprint project, which is probably a good 10 years ago. And at that time, Firefly was a part of a group looking at rapid prototyping, which has become 3D printing. So we've invited Jari to be a part of the presentation tonight because he has a technical expertise around the material technology and also the importance of the innovative software. So maybe Connor, you would open up and ask some of the relevant questions that some of our listeners might want to ask our engineer and head of research and development.
Where are you coming from this evening, Jari? Where are you in the world?
I'm right now at Newcastle upon Tyne in the UK, and in the northwest of England, northeast of England.
So tell us a little bit about how you became involved in Firefly, and I suppose from working with you, one of the most interesting things that I saw was the prototyping of products over the weeks and months that led us to where we are today, where we launched this sustainable 3D printed product. Tell us a little bit about that process that you went through.
So initially, as Martin mentioned, the footprint project, and I think the genesis of this product lies in that project where we developed a lot of the kind of background and did a lot of testing of the additive manufacturing technologies available at that time, and the design systems tailored for really this kind of design work. And basically after that, that project, which it did finish maybe 5-6 years ago, we kind of, a lot of the partners in that consortium continued that development work then with their own objectives, and I think once the technologies kind of became kind of even more mature from that project, and the right kind of balance between having the right processes, the right materials, the right design systems, kind of once we reached that level, we were then kind of in a good place to start developing this product, which started in the beginning of 2019, and basically that was quite an ambitious process, because we really kind of wanted to develop a digital end-to-end process. So you start from the clinician who does the patient assessment, does a 3D scan, and fills in the order details. And that's from that point onwards, everything is digital. And a lot of the processes in terms of order handling, the design, kind of handling the different files, that can be kind of completely automated, and that kind of eliminates a lot of the chances where something can go wrong, and we can then kind of automate a lot of that's process, so it becomes scalable and very efficient in terms of the designers and the staff involved.
I was just saying, Jari, so 3D printing regardless of the material, is more sustainable because you've less waste. And our vision by using 11, and you'll talk about that in a moment, is a plant-based sustainable material. So it's even more sustainable than say the traditional subtractive manufacturing processes. And in this day and age, I think we all have to be responsible and look at our practices and what we do. So it makes sense to, look to the future of innovative, sustainable manufacturing processes.
Yeah, absolutely. And this this polymer, not the nylon polymer, is it is indeed a sustainable material. It is made out of castor oil from castor beans, and whereas the let's say the more established 3D printing materials are usually just well, non-sustainable, or the sustainable material is mixed in with other non-sustainable materials.
What can we do with the orthotic that's 3D printed? What are the advantages of this manufacturing process that maybe we can't do with an orthotic that is vacuum formed or that's manufactured in a more traditional manner?
Yeah, so I think there's two parts to answering that question, and one is the overall process, which is a digital process for 3D printable devices, where you do not need to manually make positives or molds and then form those by hand. Everything happens basically digitally, and because of that process, you can have well, the main advantages of that, which is repeatability. You can kind of go back and, for example, if you want to remake something, you can go back to the original data and make that exact same item again. Whereas if you make it by hand, it could be that you need to start over everything again, or it could be that there's different technicians work differently, and as a result of those decisions that they make during the manufacturing process, you get a different result. So all of that kind of goes away. So it is consistent, and you can measure everything correctly, and you can also communicate where you are in the process to the customer. The second part is basically the additive manufacturing itself, which basically has very few design constraints and design freedoms, which is very new to this industry, because usually, like a thermoforming process or a milling process has its own limitations, and every company making those kind of devices has to deal with those limitations, and as a result, pretty much all of the devices look more or less the same. Whereas with 3D printing, you can kind of make almost anything that you can kind of imagine, and kind of complexity of your design, whether it's like a standard design or a bespoke design, it doesn't really matter. So you can just make complex components with intricate internal structures or meshes or logos, text, anything you can think of, just as easily as you can make a box standard product.
And yes, I've talked a little bit about that, Jari, in terms of one of the things that we want to move towards is a range of pathology precise orthoses. So we'll refer to that in the future as our PPO range. And what we're looking at is maybe for the profession, we might start to create designs that are aimed at certain pathologies, and this may in turn alter actually how we prescribe custom-made foot orthoses. So I'm quite excited about that, and I'm having lots of discussions with colleagues around concepts of, well, how would we like to offload that second MTP? How would we like to create a greater supination moment of force or a greater pronation moment of force, or how do we, create more shock attenuation right at heel strike under the plantar heel pad, things like that. So that's quite exciting as to what we can create going forward, and that will be the next step. in our journey.
Yeah, it's what's interesting is that now you can have those conversations because you can actually create something that you couldn't create before.
Yari, the last question I want to ask you is in relation to the Fusion app and the scanning process. You played a central role in in our Fusion project here in Firefly. And a question that I'm asked frequently is how accurate is the digital scanning when we use Fusion or other scanning apps in comparison to the traditional anatomy capture of plaster of Paris or foam box impressions?
In terms of the accuracy of that scan, whether that is kind of accurate enough representation of the foot itself, yes, it is, and it's being used by clinical professionals all over the world in a number of different applications, not just for foot orthoses, but for all sorts of O1P applications and beyond. And it also, there are some research papers out there characterizing the accuracy, and basically the conclusion from the studies that I've looked at is that yes, it is, for this particular purpose, it is good enough.
Okay, so nice to speak to Yari there, and thank you, Yari, for your time in joining us this evening. That kind of almost brings everything to a conclusion this evening. Thank you again for your time that you've given to us this evening. But before we go, Martin, you want to just emphasize the aspect of what Firefly as a company can offer you, the podiatrist, from an educational point of view and from upskilling?
Yeah, absolutely. I think one of the key things that we offer is sort of the educational and training component to Firefly. And I've been very fortunate to work for the last 30 years with some amazing podiatrists all over the UK. And we're constantly sharing concepts and ideas of how we improve as practitioners and how we get better outcomes for our patients. And I think that's something that if you need specific help in terms of, well, how do I use this Fusion app? You know, what's the best way to position the foot? How do I write a prescription for a certain pathology? Then really the Firefly team are here to help you there. So please don't hesitate to reach out, and then we end up working together and creating a win-win relationship.
Yeah.
So look forward to working with you in the near future.
Just to say, our technical support team are available from 8 o'clock until 2:30 each weekday. You can still contact us after 2:30, and we'll endeavour to answer all our questions. Or all your questions within 24 hours. You can email us after 2:30, or you can leave messages on our phone system, and we'll get straight back to you. One thing that we haven't spoken about, Martin, is if you're willing if you wish to place an order for a 3D printed product using our paper order form. It's not currently listed on the paper order form.
Yes, that's right. It's not listed as an option on the printed order form, so you would have to write in the special instructions at the bottom of the page, 3D printed shell. Maybe what we could do, just write on the moment, on the cuff, if there's any podiatrists there that would like a sample of the custom made 3D printed devices for themselves or for a member of the family, Firefly will offer that. So that's essentially one pair per clinic, per practitioner. So your call whether you use it for a patient or yourself or a family member. And what I would like to say is that this is an iterative process, and we want the feedback, and we want you to tell us how we keep making it better and better and better. So please take up that offer and do that. And thank you very much for joining us on your evening, and I hope you have a great evening, and let's keep in touch. Thank you.